to be part of this speaking series, and wonderful to see all of you. And I would like to invite you, we are a friendly group here. If you feel comfortable, please feel free to turn on your camera. It's always great to see the faces who you're speaking with. So yeah, so I'd really appreciate that, but I understand that that's not necessarily comfortable for everyone. So, oh, wonderful. Thank you, everyone. That's great. Hello. Okay, so let me go ahead and share my screen here. Let's see. Okay, can I get a thumbs up? Is everybody seeing that okay? Excellent, wonderful. All right. Well, hope you're all enjoying your lunch. I'm going to take you through just some thoughts about the research that we've been doing over the last 5 or 6 years now or so since I started at U of T. But a quick note about why I'm so drawn to tower retrofits. There was a student by the name of Graham Stewart a number of years ago who did a master's thesis over in the Daniels faculty all about the potential of these neighborhoods. And I was just, as a young undergrad student, I was so inspired, and it turned into a master's, which then turned into a PhD, which then turned into a research program over at the Atmospheric Fund. And here I am back at U of T, still thinking and working with these communities. So this has sort of been a long journey for me, and I'd like to just share a little bit about what we've been up to. But the thesis behind the talk today is really, I think we all recognize that we're going to have to undertake some pretty significant changes to our built environment in the coming decades, basically as soon as possible. And while we're doing that for climate change mitigation and adaptation, there are a lot of other opportunities to improve how these buildings operate. And so I'd like to go into this discussion today with that mindset and thinking about how we can leverage all of those investments that we're going to make to actually create a better quality of life for the residents in these buildings. So we'll start off just with an overview of typical post-war, I call them MURBs, multi-unit residential buildings. I'm typically thinking in the high-rise sense. I will sprinkle in a little contemporary MURB discussion as well, because believe it or not, a lot of these buildings probably require retrofits already and experience a lot of the same performance issues that we see in the older buildings. So we'll go through that. So we'll frame this talk in 2 parts. So one, looking at the challenges that these buildings face. And here I'm just going to take you through a couple of studies that we've done to kind of characterize what's happening in these buildings currently. And then we'll look at some of the research that we're doing to try to improve both energy performance and the quality of the indoor environment for residents going forward. So just a little bit about my lab first, so you kind of know where we're coming from. So we are based in engineering, but it is quite a multidisciplinary group that also involves members from the School of Public Health, the Dalla Lana School of Public Health, and the Daniels Faculty for Architecture, Landscape, and Design. So, but we really work at the intersection of this Venn diagram. I'm not sure if you can see my mouse here, but where the building envelope is what encloses our buildings, so our windows, walls, and roofs. The HVAC system is what provides heating, ventilating, and air conditioning to that enclosure. And then the occupants are why we're doing all of this. Buildings are for people, and if it wasn't for them, then we wouldn't have to worry about all of this. So, but all of these different components interact with one another quite significantly to impact performance. And so that's why we really try to keep all of these elements in mind throughout our research. And we use lots of different approaches to our work. So initially, when I started out doing my PhD work, I was focusing mainly on energy submetering, and a little bit of indoor environmental quality monitoring, things like temperature, relative humidity, understanding when and how people are opening windows and doors and things like that. But we're starting to move more into engaging residents in our work. So through surveys and interviews and a technique called photo voice, which I'll talk a little bit about as well. And then once we've collected all of that field data, we typically build calibrated models and then use those models to test out different retrofit approaches before we go out into the real building and start making these changes. So why MURBs? I've touched a little bit on the tower side of, or my draw to tower renewal, but multi-unit residential buildings more generally, I just find are such an interesting building type. So they kind of fall between the cracks they're not quite commercial buildings, but they're not quite what we would normally think of as residential buildings. And they experience a lot of issues that are quite unique to a multifamily context. So we're dealing with all of the challenges that we have with respect to high-rise buildings. So challenges controlling airflow, delivering ventilation adequately throughout the building, which we'll talk a little bit more about. But unlike commercial buildings, these are people's homes. And they all choose to use those homes in different ways. They open windows at different times, they cook, they turn on fans, they use auxiliary heating and cooling equipment. So unlike commercial buildings, which are really relatively tightly controlled, these buildings are not. And so they have to be quite adaptable and resilient to operating under these wide range of conditions. So for those reasons, most of my work is in this sector, and I'm primarily interested in social housing because I think that's where some of the biggest challenges are. There's a lot of deferred maintenance already in these buildings, and so trying to undertake sort of to go above and beyond just keeping things running is challenging, and so we need to think about low-cost ways of improving energy performance and resilience to climate change as we move forward. So just briefly, a little bit about MURBs in terms of their significance and the role that they play in the residential building stock. So residential buildings, including single family homes, make up about 17% of our national energy use and are responsible for about 13% of our GHG emissions. But when we think about the number of lives that these buildings touch, it's actually fairly significant. So MURBs currently house just over a third of Canadians, and that's even more in cities like Toronto, so upwards of about half. And they're growing. This is the fastest growing form of housing in the country. And so it's something that we're going to need to start paying more attention to in the coming years. So some of the common features that we see across both building types, believe it or not, the buildings on the left were sort of the post-war 1960s, 1970s. Buildings on the right, sort of anywhere. We've seen a boom recently in the last 2 decades. So those are kind of the two classes, two vintages of buildings that we tend to work with. But we haven't really learned that much over the last few decades. We're still seeing a lot of the same approaches to design for lots of reasonable reasons, but they sort of limit what we can do in these buildings. So for safety reasons, we generally have very limited window operation, typically no more than about 4 inches. We have what we call double loaded corridors. So you have suites located on either side of a corridor. So a typical suite will only face one direction. And then we typically have fairly low ceiling to floor height. So we don't have things like ceiling fans. And so these 3 features really limit the ability to naturally ventilate and cool these buildings overnight in the summer months. We also tend to see a very common ventilation system in this building type is called a pressurized corridor ventilation system, which essentially takes outdoor air, dumps it into the common corridor spaces and tries to positively pressurize it. So we're blowing it up like a balloon and basically relying on these little slots underneath the door for that ventilation air to make its way into the suite. We're going to come back to that, so just remember that one. And then little to no exterior solar shading. These are tall buildings, so tend to have a fair amount of solar exposure. And this is particularly a concern in the newer buildings where we've got really highly glazed facades, typically floor to ceiling, wall to wall windows. And on the post-war side, like both of these building types, quite thermally massive structure, which is important when we think about nighttime cooling during extreme heat events. And these buildings typically have no central cooling. So they typically rely on those little window units. If the person in the unit is able to afford to install that, great. But that's not something that's universally available to people in these buildings. So as a result of all of these features, there are a lot of common challenges between these different buildings. So we tend to see high energy use intensity, significant indoor environmental quality issues related to thermal discomfort, olfactory discomfort, acoustic discomfort. And then we also need to consider, again, in light of a changing climate and more severe weather events, which could lead to power outages, some of the challenges that we're going to face with respect to mobility and access to water if we need to shelter in place for longer than a few hours. And then specific to the particular building type, we're starting to see pretty dangerous summertime overheating levels in these post-war buildings. And then we have visual comfort issues as well in glare in these high-rise buildings. So now now that we have a sense for the features that sort of link these two groups, but also separate them, I just want to take you through two different studies, actually three different studies, one focused on the post-war building set and another focused on newer buildings. And we'll just sort of look at what we uncovered, basically the current conditions that we're dealing with in these buildings. So this was a study that I started on actually when I was at the Atmospheric Fund before I joined U of T, but thankfully was sort of looped back in. One of my collaborators was at U of T, so I was able to rejoin the team when I came back. And this was a study that was undertaken because a social housing provider was undertaking fairly significant energy retrofits, and they wanted to understand what implications these energy retrofits would have for the residents. And so we went in and undertook a fairly significant in-suite monitoring campaign and accompanied that with resident surveys before and after the retrofit. So we looked at, we did this in-suite monitoring a year before the retrofit, during the retrofit, and then a year after that. And so just collected a whole bunch of different data, but I just want to give you sort of a high level overview of where things are at. So there's a lot going on this plot. We've got the summer months on the left-hand side here and the winter months on the right-hand side. What I want to draw your attention to is these wider bars, which basically combine all of the respondents from all of the different buildings. Red is too hot, blue is too cold, green means good. So when we look at the summer months, where over half of the residents across all of these buildings were experiencing thermal discomfort, warm thermal discomfort, so overheating. And interestingly, in the winter months, we were actually seeing a combination of some buildings, the high-rise buildings, were experiencing significant underheating, so cold thermal discomfort. And we were also not experiencing not an insignificant amount of overheating. So this might be signaling, heating systems that don't have in-suite control, which is very common in these buildings. And so residents tend to modulate their heating system simply by opening the window, which I hope you can appreciate is not the greatest for energy efficiency. And then, so that's sort of looking at things from the residents' perspective. But when we actually looked at the monitoring data, it was quite shocking to see the really extreme indoor temperatures that we were seeing. So just if you, I don't know how easy it is to see these numbers here, but this upper end of the scale sort of goes up to the high 20s, low 30 degrees Celsius. And the other interesting thing when you kind of zoom in to what a daily profile would look like, we looked at some of the hottest days during our monitoring period and found that, as one would expect, so this is from midnight one day to midnight the next day. So you can see that, over the course of the evening, the outdoor temperature, the black line here, comes down quite a bit. So there's a potential for free cooling via natural ventilation to try to bring the temperature of these buildings that don't have central cooling down. But because of the thermal mass in these buildings, the temperatures really don't decrease in a measurable way at all. So you can imagine how much heat actually builds up over the course of a multi-day extreme heat event and basically making these suites uninhabitable. So moving on from thermal comfort, we also looked at olfactory discomfort. So what sort of things do you smell in your apartment? It makes sense in a multifamily space. People are doing lots of different things. Some things they perhaps shouldn't. and the result was that we found more than half of people were bothered by this every single day. So imagine being bothered by something like that every day in your home. That is not insignificant. And this is a combination of a variety of different things. Smoking in buildings that should otherwise be non-smoking, your own cooking from your neighbors, and outdoor sources as well. So let's shift gears. We know there are some problems in the post-war sector, but I also wanted to highlight that we're still seeing a lot of these challenges in newer buildings as well. And so as part of a larger study that we did on the impact that smart thermostats can have on building energy use, we recruited two fairly new condo towers, both located in downtown Toronto, both with these fairly highly glazed envelopes that I mentioned earlier in the presentation. And we undertook a similar sort of approach. So we used resident surveys to understand what their perceptions of thermal comfort, among other things, were. And then we paired that with long-term in-suite monitoring of temperature and a number of other indoor parameters. And what we found, frankly, was not that different. So about half of the residents are uncomfortable in the winter and uncomfortable in the summer from a thermal comfort perspective. And the difference here is that these buildings have central cooling. They have in-suite heating and cooling controls, and they were still not able to achieve thermal comfort for the residents. We also found that over-conditioning was common. So what I mean by this is with that central ventilation air that I mentioned that's sort of driven into the common corridor spaces, that was over-conditioned to the extent that it was conditioning the suites, so providing heating and cooling into the suites. And for long periods of time, the thermostats in the suites wouldn't even turn on. So that's a signal of, okay, so we've got some excessive energy use here, and so we can try to reduce energy use that way. The other interesting thing that we gleaned from the surveys was that residents would prop their windows open, maybe not unsurprising, not necessarily surprising, but they also propped open their hallway doors. And so if you can imagine when you're trying to control where air is moving, if you all of a sudden open up all of these interior and exterior partitions that were originally intended to be closed, it makes it a lot harder to operate these central systems. So it's, I guess, in that way, not unsurprising that we're seeing such serious performance issues. And then stepping into a different dimension, so we talked a little bit about thermal comfort and ventilation. Another major challenge, is I think everyone can probably appreciate when you're living next to a bunch of other people, is acoustic comfort. And so we undertook a fairly large study involving surveying people in over 30 MURBs, but over 200 respondents, to ask them how they felt about the noise that they heard in these buildings. And in this plot that you see here, I'll just draw your attention to the bolded columns here, one looking at overall outdoor noise, and on the right here, looking overall indoor noise. And here, green does not mean good. Green is still annoyed. So green is slightly annoyed, and we progress up to extremely annoyed in red. And so you can see that 70 and 80% respectively of residents are annoyed with indoor and outdoor noise. So this is a major problem in these buildings. And then the impact that this has on residents, everything from sleep disturbance to affecting their mood to making it harder to work and study. This was a pre-COVID survey, so I can only imagine that these effects have increased with the widespread work from home orders over the last 18 months. And then what's interesting too is to look at how people respond to this. So some of the things, might actually make it easier to control airflow, these first two actions, but some of them are quite interesting. So some people actually create their own noise to mask other people's noise, which actually makes the whole problem worse. The other one I just wanted to highlight here was some people weather strip their suite door. Now, if you remember back to our pressurized corridor system, where is our ventilation air coming from? It's all coming from the corridor by that suite. So in order to deal with an acoustic comfort issue, people are essentially cutting off their access to outdoor air. And so I mentioned that because I just want to highlight that all of these things are working together as a system. You can't just deal with one. Everything really affects everything else. So now that we have a sense of where things are at, let's look ahead. So what are these challenges are these buildings facing? I think we're all aware that we're going to be seeing increased maximum temperatures and extended heat waves. And the impact that that's going to have on our built environment is positively, it's going to decrease our heating load, which is good, but it's also going to significantly increase our cooling load to the point where these buildings will require cooling beyond the capacity that they were designed to provide this cooling. And unfortunately, social housing is actually going to be most significantly impacted because of that lack of access to active cooling. And as we, start to undertake this, what is going to be a fairly dramatic transformation in the built environment, we need to keep in the back of our mind that this is not just, reducing building energy consumption to reduce our GHG emissions to mitigate the effects of climate change, we're also going to need to start adapting to this changing climate. And we need to keep both of those pieces in mind as we approach changes to the buildings. So, I mean, the short story is that we need some fairly deep retrofits right now. I mean, we should have been doing this for quite some time, so there's no time to delay. And these need to be reducing both operational and embodied emissions, but at the same time adapting to a changing climate. And so what I'm proposing here is we're going to be investing millions and millions of dollars per building, billions of dollars across the country in this. So let's take this opportunity to think more holistically about building performance and address all of the other issues that we've spoken about in the last few minutes. So one project, this post-war housing project that I mentioned at the outset of this presentation, the PhD student who was working on this project, interestingly undertook a life cycle analysis, because I briefly mentioned that embodied carbon piece. We need to be cognizant as we reduce our operating energy use. The embodied carbon in our buildings and the decisions that we make with respect to retrofits is going to become a bigger piece of our carbon pie. And so she undertook this life cycle analysis. Now, this was a primarily mechanically driven, just replacing major mechanical components. And so the life cycle carbon savings as a result of these improvements is really a no-brainer. The embodied carbon was virtually nothing. But when we start to do things like replacing windows and overcladding, meaning basically putting a coat on the building, adding this exterior insulation, those are going to have far more significant impacts on embodied carbon. So we need to keep that in mind as well. But what was really interesting was the data I showed you before was the pre-retrofit data. And what we tried to do was compare pre and post-retrofit. Did these retrofits actually have a meaningful impact on the residents? And the answer was no. I mean, there really wasn't a significant and consistent change between these buildings. Some buildings saw a slight improvement, some buildings saw virtually no change. Now, to be fair, though, there were no explicit thermal comfort goals in this project. This was purely to reduce GHG emissions of the building. But what that tells us is that we need to build these goals right into our retrofit projects, because what we saw from this across 7 buildings, very similar retrofits didn't necessarily yield the same result in different buildings. And it's really difficult to predict how occupants are going to react to these different interior conditions. So we definitely need more research on that piece, which is something that our group is actively working on. Then that these mechanical retrofits have low embodied carbon, but we've already talked about that, so that's okay. So what I'd like to do now that we've sort of looked at the challenges that these buildings face and what's going to be happening in the future, I'm just going to sort of present you with a bit of a teaser, a couple of studies that we've been doing to try and get at this piece of energy and improving comfort and well-being and improving the experience for the residents. So in those newer buildings that I mentioned before, these buildings have only just been completed and occupied. So I think they were both 2017 or 2018, I can't remember. I apologize, both my kids are home awaiting COVID tests, so there's going to be a little bit of screaming in the background. They've just come home. So with these buildings, what we did was replace the non-programmable thermostats with smart thermostats to see if we could alter the control algorithm to try to reduce energy use without having any noticeable impact on thermal comfort. That was really the goal of the study. And so we were able to glean a whole bunch of different things from the study, one of which was smart thermostats tended to be programmed at a much higher rate than a standard programmable thermostat. We are typically not very good. On average, only about 30% of programmable thermostats are actually programmed. Here we saw an increase up to 83%. So that's already a great step in terms of trying to reduce energy use. And then we also found that occupancy-based control. So what I mean by that is having an occupancy sensor that looks to see when you're home and when you're not home. And when you're not home, it will reduce or increase your set point temperature in order to save energy. So that was quite a useful function as well, and could reduce almost 80% of avoidable demand just compared to as if you were just running a schedule. So it allows these systems to adapt to your actual occupancy schedule. The other interesting piece was the diagnostic capabilities of these connected thermostats. Was we were actually using the data to identify other problems, such as the overconditioning that I mentioned. So even though this is a suite-based technology, it allowed us to detect issues that were happening with the central system that could be another means of both improving occupant thermal comfort and reducing building energy use. Flipping back over to our post-war buildings, some of you might be familiar with how these buildings are operated, but some of you might be shocked to hear that there are often 1 or 2 thermostats for the entire building. And so there's really no in-suite control in a lot of these buildings. As I mentioned, people simply modulate the temperature in their suite by opening and closing the window in the middle of the winter. And so we were thinking, okay, is there a way to, rather than retrofit every single suite with a thermostatic valve and a thermostat, which is very expensive, can we strategically place valves and use remote temperature sensors to group suites that have similar space heating needs, and then dial just segments of the building down to try to reduce set point temperature and try and reduce the instance of that window operation. So this was a study that we did. It was a simulation-based study, although we are looking at doing a pilot in a building soon. And what we found, just to orient you here, so we have energy reduction potential on the left-hand plot here, with up to 25% if we were to outfit every single suite with a thermostatic valve and a thermostat. So that's obviously not ideal because it's quite expensive. And then on the right-hand side, we have overheating reduction. So the potential for that particular grouping solution to reduce overheating, which obviously has an energy impact as well, but and a thermal comfort impact. So, so then I've just color-coded these by payback period. Most building owners would balk at anything more than 10 years. So, so there are some interesting opportunities here that can yield a fairly significant space heating energy savings reduction, these 2 green scenarios here, and also reduce that overheating. So it has that knock-on effect of potentially reducing that window operation as well, which is great. So hopefully we'll see those results bear out in our field trial as well. And then coming back to these ventilation challenges that I mentioned before. So we've been working with some housing providers to look at feasible retrofit strategies for these systems. And so we did a simulation study to investigate how these different systems might perform. And one thing that was really shocking to us, which I guess is kind of explainable as well, but is the amount of air in your suite that's actually coming from other residents. So you have in this plot here on the left-hand side, you've got these gray bars, which represent the amount of air that's directly transferred through walls and ceilings and floors. But we also have a fairly significant amount of air that's going out into the corridors, coming up, mixing with other people's air, and then re-entering suites in the upper half of the building. So this is something that particularly in COVID times, we need to be mindful of and do a better job of controlling where our air goes. And I'm cognizant of the time, so I'm just gonna flip through here. Sorry, I guess my main takeaway with this one was there are lots of opportunities to improve how these systems are operated. And one of the things that we found was that it doesn't matter so much what system we choose. We're still seeing a lot of challenges, even in sort of what we would think are sort of the best solutions when you look at sort of a decentralized ventilation system. But what we've turned our attention to now is actually sealing up all of the interzonal partitions, things like elevator doors and suite doors, stairwell doors, to try to really control where that air goes. And so that's what we're working on right now, but lots of potential here. And we're about to undertake a field study on this one as well. And then the last study I just wanted to mention briefly is we're going kind of in an even broader direction now. So I kind of went from energy use to indoor environmental quality parameters to resident perceptions of comfort. And really all of this feeds into resident well-being. And so with partners from the Faculty of Architecture and School of the Environment, we're undertaking this interdisciplinary study looking at how elements of the built environment can add to or detract from well-being. So as we're approaching these retrofits, are there other things that we can integrate into our retrofit planning in order to improve the well-being of residents? So just a few concluding thoughts, and then I think we'll open it up for questions. MURBs are growing. They're the fastest growing source of housing in the country. So they do represent a growing concern because of all of the issues that I mentioned. And on top of dealing with all of those performance issues, we absolutely must be reducing their GHG emissions significantly and adapting these MURBs to deal with this increasingly warming climate. But it's not as easy as just replacing single components. We really need to think about these buildings as a system and how all of these different components work together to influence the experience of the residents. And I do think it's something that we're working with some industry partners to go beyond simply having GHG emission reduction targets, but actually establishing specific comfort and well-being goals and building those right into our retrofit performance assessment frameworks. So I just want to very briefly acknowledge all of the work of my collaborators and students. This is a collection of a bunch of different master's and PhD theses. So many thanks to them and all of our industry and government support that has paid for this research. So thank you so much. And I know I sort of blasted through a bunch of those studies, so happy to answer any questions or clarify things now.
Well, thank you so much. That was just fascinating. And, I have so many questions, and I'm sure people do as well. I'm thinking I'm going to start out with a couple low-hanging fruit questions, and then maybe others can put their questions in the chat or speak up if you like. I'm just going to give a hand here to Professor Touchie. So I have a quick clarification question and then a bigger question. So the clarification question is, when you did the survey and you found those results, and a tremendous number of people are uncomfortable, but I started wondering about sample bias and selection bias. And so are they, is the sample you were looking at particularly likely to be elderly or disabled, or, are there other issues there?
So in that first study with the post-war buildings, it was interesting because we didn't realize this at the time, but each site had a different population. So we had 2 seniors buildings. We had 3 seniors buildings, 2 that were primarily bachelor suites, and then 2 that were families. So we did get a distribution. Everyone in the building was eligible to participate. We didn't choose the participants. But certainly if people had longstanding issues with the building, selection bias could have been at play because they may have wanted to voice their opinions about the building.
Yeah. Right. Very interesting, though. A lot of uncomfortable people. It's really striking. Yeah. Okay, a question has come in to me privately, which is about building height. So, was there significant differences between where units were in the building in terms of their positive or negative experiences of comfort?
We thought that would have been the case, but there was not a meaningful difference in a statistically significant difference. And we basically partitioned the building into thirds and compared the top third and lower third, and there wasn't a significant difference. So these were fairly widespread issues and fairly strangely not uniformly distributed, but we were seeing similar issues no matter where you were in the building, which when you think about the physical phenomenon driving a lot of this airflow and stack effect and that sort of thing, we would have expected different things. Like we would have expected, significant infiltration of outside air on the lower part of the suite. So probably a lot of cold discomfort in the wintertime, and the reverse up top. But we did not see that.
Uh-huh. Okay, there's a couple other questions coming actually from YouTube, since you're being live streamed too.
Oh, cool.
So,
hi, YouTube.
yeah, right? So from Annie, the hallway in my building is quite chilly now as the vents are blowing cold air. Are you saying this is intentional? Can it be improved to provide fresh air but be at a comfortable temperature?
Yeah, so at this very moment, what's probably happening, because it is, I'm assuming Annie or Anne, I'm sorry, is in the Toronto area or somewhere. I guess YouTube could be anywhere in the world, but you know, if it's cold outside, what's probably happening is they're trying to save energy by reducing the amount of tempering that's done to that indoor air. So rather than bringing it up to all the way up to say 22 or 23 degrees, they might be trying to reduce energy by just providing cooler air to the suites if it's cold outside. Really, a corridor is a transient space. So it's usually a place where we're walking in with our coats and things on, and you kind of get back to your normal indoor clothing level once you've entered your suite. So that is a potential for energy savings. But this is where I think the interaction with policy is interesting, though, because we need to provide a certain minimum indoor temperature in these buildings. And similar, I'm just sort of going off on a little bit of a tangent here, but I remember TAF was working with, I think it was the city, maybe on common area lighting in parking garages. There was this huge opportunity to reduce lighting energy use by installing motion sensors, but you had to provide a certain light level in the garage at all times. And so somehow they were able to work through the policy side of things. But I'm not aware of where things are at with the temperature piece, but I think it's a really it would be a really important place to try to save energy in the common areas, is to keep those corridor temperatures lower in the winter and warmer in the summer.
Right, great. Okay, another YouTube question from James Moffat Johnson. Marianne, fascinating breakdown of the pressure difference issues in MURBs. Are you aware of any Ontario-centric data sets on MURBs? From a public health point of view, they are poorly captured in most open access databases.
Yeah, I sympathize. There's not much out there. I mean, we've tried to create, we did a project back in 2013 that tried to assemble a bunch of different existing data sets. So we've got this data set that's looking at energy performance and seeing if we can correlate different building features with energy, but that was only about 100 buildings. There's also the large building energy and water database from the province, of limited utility because it doesn't have key details like I think floor area and building vintage. So we're not, the short story is there's not a great resource. Depending on what you're looking for, I mean, feel free to send me a note and I can see if I can direct you to the specific kind of data that you're looking for, but it is a huge challenge. MURB data sets are not well captured. Although I must say there's a new, relatively new, I think it's about 2 years old, survey, the survey of household energy use, which is really helpful. They now have a MURB version of that, which is fantastic. So that's a step in the right direction at the national level.
Oh, great. That's super helpful. I love this term MURB, by the way. So a question from Laura. Can you talk a bit more about the research related to ventilation between units and how you plan to monitor improvements of increasing the air tightness of units?
Okay, so there's two different things there. One is air tightness. So tightening up both the envelope and the interzonal partitions like walls and floor slabs and walls to the corridor. And with that, what we use is a technique called blower door testing. So we essentially open up the suite door and replace that with a door panel that has a calibrated fan. And using that, it's a little more complicated than this because you also have to sort of pressure neutralize the surrounding suites. You can one by one isolate those 6 sides of the suite and determine what the air tightness value is, or you can do a whole suite test, which sort of gives you a combined air tightness of all of those partitions for the suite. So one way you could do that assessment is before and after some sort of air sealing retrofit to determine that. And then on the ventilation side of things, that's a little more complicated. So the study that we're about to undertake in 2 buildings, we're very fortunate. We're being provided access to twin buildings, one of which is retaining their pressurized corridor system and the other is switching to a decentralized system. And so we'll be using a series of differential pressure sensors to kind of monitor how airflow is changing across the interzonal partitions and the exterior. And then we'll also be using occupant perceptions, things like odors and how fresh they feel the air is before and after the retrofit, but also a number of IAQ parameters and just seeing if there are any major changes to concentrations in the suite before and after the retrofit. I'm not sure if that answers that person's question, but I'm happy to elaborate further. Oh, I think Graham had a question too.
Go ahead, Graham. Do you want to unmute yourself?
You're still on mute. Oh, Graham, you're still on mute. Can you hear us? You're on mute.
Oh, you're muted.
Oh no. Do you want to pop your question in the chat? Because we can't hear you.
Yeah, we can't hear.
But
yeah, well, pop it in the chat and we'll come back to you when we can hear you. Oh, there you go.
Sorry.
Great.
You were not allowing me to unmute. You big
I see. Sorry about that.
So John Godfrey, and I used to be Federal Minister of Infrastructure and Cities, so I have an interest in this subject. Very quickly, if you were to take the problem of tower renewal broadly or narrowly defined, whether you want to talk about all classes of buildings from social housing to co-ops to rental to I live in a co-op. You're looking at one right here, and it was built in 1960. You know, there's something like 2,000 buildings like this, at least, in Toronto high rises. The work you're doing is fantastic, and maybe we need to have an offline conversation, Marianne, but are you working with other parts of the university to figure out the big problem, which is retrofit financing? People have been looking at tower renewal for ages, and I think that within the University of Toronto, there are enough elements that, given your work, given what they might be able to do at, say, Rotman or wherever else, given the public policy component of, is there public money available? But we need to bring all of these stories together to get the job of deep retrofits actually financed. Are you cooperating with other elements to deal with these other parts of the problem without which we're not going to get anywhere?
Not specifically, but I completely agree. This is going to be the biggest barrier to moving forward. I mentioned I used to work for the Atmospheric Fund, and they started a oh my gosh, energy efficiency capital,
yeah.
Maybe I've got it wrong. Sorry, which I think is exactly the kind of financing vehicles that we need to start moving this forward, but we need it to be available on a broader scale. This is maybe actually something that we could work with through the School of Cities to bring people together from Rotman. I would really love to work on that. It's not something that I have expertise in, but I completely agree that it's got to be overcome if we're going to make any meaningful impact on this in the coming years.
If I may, then I will contact you offline and we'll pursue this conversation.
Please.
If that's okay.
Yeah, that sounds great. I would love that. Thank you.
Yeah, that would be fabulous. And it's such a great point. And this is a problem, it's a multidisciplinary problem, and we should have multidisciplinary perspectives on it. So
definitely.
Right. I had a kind of related question, on implementation and how do we move forward. As you were speaking, I could envision how you would go about solving the problem for social housing or big institutional actors. And so there's sort of a set of low-hanging fruit where you can get economies of scale, and you might like replace all the boilers in all the social housing, or replace all the windows and at the U of T dorms. But so that there's that piece, and then I started wondering about the private piece, the private landlord and private owner piece, and what does the city? What would the program look like if the city or the province were to pass some regulations like New York City's, program of mandatory energy use for buildings over a certain size? If we were to do something like that, what would be the low-hanging fruit for the private sector to move forward?
Oh, see, I hesitate to even say what the low hanging fruit is going to be, because when we talk about low hanging fruit, we talk about boiler replacements and things like that.
Mhm.
And that should really be the very last thing that we're doing. We need to do the tough stuff. We need to be air sealing. We need to be overclouding. We need to be replacing windows. We need to get the ventilation system right before we do anything that could be remotely classified as low hanging fruit. So I don't want to encourage that approach. I think we need, if we're going to do this, it's got to be a holistic retrofit. And that's perhaps, I get that that's me coming at this from an academic perspective and in my highly idealized view of this. But my worry is that if we don't address all of those other problems, we're only going to get so far with increasing appliance efficiency. And it's not going to be enough to get us to even near net zero, which is where we need to be. Sorry, I've kind of derailed your question a little bit.
I love that. No low hanging fruit. I love that.
There really is no low, like we've done it already. We've done the lighting replacements, we've replaced the water fixtures and things like that. So, but I think for the private sector, it really comes back to the comment before, is what financing is available that can really extend. I can't remember what this particular mechanism is called, but it's where the investment gets tied to the property taxes, so it ends up being I think sorry, it's escaping me right now. Oh, you're muted still. Oh no.
PACE, property assessed.
Oh, PACE, thank you.
Property assessed clean energy.
Thank you so much. Yeah, I couldn't think of the acronym. So something like that at the MURB level would be useful. I also think, and I don't know enough about this to comment beyond pointing people in this direction, but energy sprung is something that I want to look into. I know in Europe, they've been looking at this as a way of streamlining the procurement process for deep energy retrofits in multifamily buildings. I think it's been primarily in the public sector, but there may be some private sector examples. So one of my students is actually going to be looking into this, and we're going to be speaking with TAF about it as well. So that's just something I'd love to learn more. If there's anyone on the call today who's aware of Energy Sprung, I'd love to connect with them on that as well. I'd like to learn more. I think we need to make it a lot easier for people to do this. We need to reduce the risk. And that happens through pilot projects, which is, I know what TAF and others are doing right now. Every building is different, but they experience a lot of the same challenges. And so we can come up with a series of, I think, sort of best practice retrofit strategies and a timeline over which that needs to happen. You do this first, and then in 2 years later, you do that, and then you do this, and then you do that. I think that's what we need to work at, is what does that roadmap look like? And then have the financing in place to support those projects all the way through to the end. Because unless we get that entire deep retrofit done, we've just missed a huge opportunity.
Mm-hmm. I'm curious also if you see the link to green manufacturing in Canada. Is there some potential to link this to an economic development strategy for windows or?
Oh, definitely. I mean, one of the things that we're talking about right now, which is really exciting, is using prefabricated overcladding panels that have the windows right in there, even going so far as to have some basic suite level HVAC all built right into a factory built panel. So it makes the retrofit process really quick, easy to replicate. Manufacturing needs to happen locally. So it's potentially a jobs creator as well. That's another place where I actually think maybe the School of Cities can help create some of those relationships. We're just having conversations with a startup that's actually based in Brooklyn. But I'd love to find some Canadian, potential Canadian partners to explore that further, because I think there's a lot of potential there.
Yeah, great idea. We'll add that to the list for sure.
Sure.
So I would be remiss if I didn't ask you about equity issues. So that's a core principle of the School of Cities. And so, what are the types of equity issues that come up when you think about retrofits?
Well, it kind of what I mentioned right at the very beginning, a lot of these, a lot of social housing, first of all, people don't have a lot of choice on where they live, even where they live in the building. They're exposed to if they're in the top of the building, they're exposed to other people's pollutants, but they might not even have a choice of being able to move out of that building. And a lot of these social housing providers face huge maintenance backlogs. And so to, even dealing with life safety issues is sometimes a challenge. So how do we move beyond that and say, okay, well, we're going to actually try to improve the lives of these residents who don't have the freedom to choose their housing. So this is why I think social housing really needs to be the priority, because other people can make informed choices and they can choose to sell their condo and move to another building based on whatever that performance is like. So I do think there are huge equity issues tied to this. And it should really be the driver of where we're devoting a lot of our energy and efforts and focus as we move forward.
Great, terrific. That is, we're going to have to wrap up. I see there's a comment in the chat about Nexi.com could be a potential partner.
Oh, great. Thanks,
so
Ahmed. Yeah, I'll take a look.
Look into that.
Yeah.
And I just want to give another round of applause for Professor Touchie, and thank you so much for coming, and really a great pleasure. And I'm getting the feeling that you have launched a whole new set of conversations with School City. So thank you so much.
Well, thank you again so much for having me. It's been fun. Thank you.
Bye-bye, folks, and we'll see you next time. We'll have Jill Carter coming on December 8th. She's a professor of drama, theater, and performance studies, and she'll be talking about the need to understand the land that we stand on. So thank you very much.
Thanks, everyone. Bye.
Marianne?
Yeah.
Okay. Can you give me your email?
Oh, sure. Should I just pop it in the chat?
Yep, please do.
Yep.
Maybe we should think about convening a conversation. I know this is the